Hi everybody, welcome back to the Coding and Analysis YouTube channel. And in part 2 of this AVM model that we're trying to run, we are going to apply our model to the new listing data. In the previous video, we did a walkthrough of this, how we determined our XGBoost model with cross-validation and best boosting rounds to predict sold prices, and now we're trying to predict the sold prices for current listings in our listing dataset. So we make our new custom function called apply model to method, and then we have our parameters test data, model, and features. So this applies a trained model to predict prices on new property listings. Arguments of parameters is test data, data frame, test data set contain new listings. The model is our train XGBoost model, which is really coming from here, this final model, which is our train model, and we call it model here. And then features list of the feature column names used in training. And then returns the data frame or test data with predicted prices. So we start off with getting our X. So this is the features in our test data. Select feature columns from test data, fills missing values with 0 and resets the index. And then we have our D matrix test, converts the test features to the XGBoost D matrix format. And we covered that in the previous video, so we're converting to this specialized XGBoost data structure, but the data is our features in our X, and then the name of the features, which was up here. So these features, and then we get our test data reset index of test data for alignment. So this is our new data frame right here. It's going to be called test underscore data. And then predict, we're using a log scale, convert back to dollar scale. So we have our preds underscore log, and it generates predictions on test data using the train model in log scale. So we have this model, which we got from right here, which is really our final model, our final train model. And it's going to be model.predict method, and it'll be D matrix underscore test. So it'll be this, the D matrix data structure right here that we filled out the information in. And it converts predictions back to dollar scale using XPM1. So our model is predicting on the prices, or it's predicting on the test data using the trained model right here. And then we're converting our predicted price. We're making a new column called predicted price, and we're putting our preds underscore log into here, but we're bringing it back to dollar scale instead of log scale. So this is where we're going to get our predicted sold prices for the current listings. And then we're going to add a column in our data frame called data split, and it's going to put test as to mark these predictions as the test data. And then we're going to return in our data frame address data split, which will be test, property type, single family, and our predicted price right here, this column, which is our preds log with our final model dot predict on the D matrix testing data, this specialized data structure from XGBoost. And that's where we get this predicted price. Then we do the convert it back to dollar scale right here. And then we're looping through the property types, which want to have single family for both of these. So we start off with empty Python list right here. And then we do our for loop, train and predict for each property type. And we're appending our results into these empty lists. Runs cross validation. So you can see here our train model is going to equal, train model is going to equal train and predict. Our custom function at the top that we started off with in the previous video. And these are the arguments or parameters, property type, features, number of folds. And then in the same for loop, we apply the train model to new listings of the same property type, single family property type. And it's going to be test underscore subset. It's going to create a data frame right here. And in this data frame, test subset, train model, and features. So this was our custom function that we saw in this video that we started off with. And as you can go back and see, test underscore data. So this is our data frame, test data set containing the new listings. So this is our current listings data frame. And then this is the train model that we ran that we got from here. See train model. And then we get our features, which is the square footage, beds, baths, waterfront, private pool. And then we append the results into this empty Python list, applies the train model to new listings of the same property type, storing predictions. Thus, we start off with this one in the for loop runs cross-validation and training for each property type, storing non-empty predictions, which they're all the predictions will be filled out because there were no non-empty numbers. There were no empty numbers. They were all filled out. So we're storing our predicted sold prices. And then in the same for loop, after we run the train model, it applies the train model to the new listings of the same property type, storing our predictions or our predicted sold prices for the listings. And then we're just combining and exporting our results right here, concatenating the all predictions data frame, the test predictions list data frame. So these are our two data frames we have now. And then we're exporting these to a CSV file. And we already have the we already had this XGBoost cross validation results. We went over that in the previous videos. And now we have our new CSV file, the new listings underscore predicted. And this will show the predicted sold price for the current listings in our listing data set. And you can see here our single family residential, the only property type we use, the best MAE log scale is 0.2136 at 64 rounds. So that was our best. That was the best MAE for the single family residential. And we have our normalized importance. Bass was at 33, waterfront 25%, square feet at 23. These were doubled. As you remember, I talked about we increased these. You can see latitude and private pool and HOA and longitude year built. These are smaller while these were doubled, I guess. So this is our feature importance. And this is the feature importance for both our train model and our predicted prices on the current listings. So all predictions, test predictions, they have the same feature importance. And one thing I want to talk about, the final model and model are the same thing in this context. So we have our final model right here, our trained model, and then we're bringing the model into here, but this is really the same thing. And I explain it here. The final train model and train and predict custom function is returned as trained model in the loop and passed as the model parameter to apply model to the new data custom function. The naming difference, final model versus trained model versus model, is simply a matter of variable naming across different scopes. So final model is used with train and predict custom function to denote the final trained model, and then trained model is used in the loop to store the returned final model. Then just our model is used as a parameter name in the apply model to new data custom function to refer to the same trained model. And then for each property type, train and predict, this custom function trains a model of the final model and returns it as the trained model. The loop passes trained model to the current listings or apply a model to new data as model, which it uses to predict prices for new listings of the same property type, which we're just using single family in this example. And this ensures the predictions on the test data are made using the model trained specifically for that property type. Then when we talk about final model versus trained model versus model, it's really all the same thing, but just in the context of the different custom functions that we're using it with. So this is all the same. It's just our models predictions based on the sold prices that we did at the beginning right here in this custom function, the train and predict underscore CV2. So this is where we get the final model and training model. So it's really all one. It's just in the it's just different context. So that'll be it for this video. In the next video, I'll do some analysis of these listing results and see what kind of results we get. If we get wild outcomes, or some of them are within variance, or some of them are out of variance, large variances. So that'll be exciting. I'll look at that in the next video. Thanks for watching.